This video is about one of the conic sections, the hyperbola. By definition, a hyperbola is defined by all points in a plane where the difference from two fixed points, which we call the foci or foci, are the same. So in this picture, we have a hyperbola. And just to show you, by definition, we've got our foci or foci here. This is one, and this is another. The difference, so if there's a picture, or if there's a point on the line, on the hyperbola, if we find the two distances from that point, to the two foci, and we subtract the smaller distance from the larger distance, that difference will always be the same. So if I had a different point, the difference between these two distances would also be the same. So a hyperbola, the equation, looks very much like the equation of an ellipse. The standard form is x squared over a squared minus y squared over b squared equals 1. In this case, because the x square is positive, we're going to open in an x direction. Notice that the center is 0, 0. We have two axes. One of them is called the transverse axis, which contains the vertices and the foci. So our vertices are these 2 points here, and of course the foci we've already marked. That's the transverse axis, and then the other axis, the line that goes right between those two pieces, is called the conjugate axis, and that will contain any y-intercepts if we have any. And then our foci. Now look at the difference between the equation for the foci here and the equation for the foci with an ellipse. For a hyperbola, we have c squared equals a squared plus b squared. So it's kind of interesting. For a hyperbola, this is minus, but to find the foci, this is plus. And for an ellipse, it's reversed. Now, I said something about this x squared being first or being positive, and that's how we know it opens on the x-axis. But we could also have a transverse axis that was vertical. So remember that transverse axis is between the two pieces of the graph. In that case, it would look like y squared over a squared minus x squared over b squared equals 1. And we still find our foci, c squared, the exact same way. But remember that that's going to be on our transverse axis, which is this axis here. So our two vertices and our two foci are going to be on that transverse axis. And again, this is through the center. Our center of this is 0, 0. You may notice on this picture and the previous picture that we have these diagonal lines that go through the center, and that our hyperbola kind of hugs that line. These are called the asymptotes, and when we're sketching a hyperbola, that's usually the first thing that we sketch. So let's look at a couple of examples. Let me go back. For this first example, we have x squared over 4 minus y squared over 36 equals 1. And we can see that our center is 0, 0. And just like the ellipse, in the x direction, go 2, because of the 4 there, 2 squared is 4. And in the y direction, we'll go 6. Now, at this point, if it were an ellipse, we would draw the ellipse. But because it's not, because it's a hyperbola, we draw this, what I like to call a magic box. And that magic box goes through those points. And we can draw a diagonal through the center and the corners. And that will be, let me make that dashed. That will be our asymptote. Okay, because our x squared is first and positive, we know this is going to open in an x direction, and it's going to kind of hug these asymptotes. So it's going to look something like this. Now, if I wanted to find my foci, I would take my c squared equals 4 plus 36, and I would get c equals plus or minus square root of 40, which becomes 2 root 10. And the square root of 40 is about 6.32. So we can say that our foci, 2, 4, 6, are here and here. So if you wanted to know what these were, it's going to be 2 root 10, comma 0, and minus 2 root 10, comma 0. So let's put all of this information down here. We knew that our center was 0, 0. Our vertices were 2, 0, and minus 2, 0. In this particular case, there are no intercepts, no y-intercepts. Our x-intercepts are actually our vertices. Our foci, we've already written down here. And what about those asymptotes? Well, each one of these asymptotes is a line, and the y-intercept is 0. So we need only to find the slope. So from here I went up 6 and over 2, and rise over run, 6 over 2 would be 3. So this is y equals 3x, and of course the other direction would be y equals minus 3x. Let's take a look at this example. we have a hyperbola here, but it's not in standard form, and we still would like to find the center, the vertices, the x and y intercepts, and the asymptotes. So just like an ellipse, we need this set equal to 1. So if I divide everything by 400, I'm going to get x squared over 16 minus y squared over 25 equals 1. And for me personally, even though I could find everything without sketching, it's easier for me to sketch this. So I know that my center is 0, 0. So we're right here at the center. In the x direction, I'm going to go 4 because 4 squared is 16. And in the y direction, I'm going to go 5. And I'm going to get this magic box. That's what I call it. It's magic. So just horizontal and vertical lines through those points. And then I will draw my asymptotes, which have to go through the corners and the center. So our asymptotes, we can see right now, have a y-intercept of 0, and we went up 5. From here we went up 5 and either right 4 or left 4. So we get 5/4 x or minus 5/4 x for our asymptotes. Again, because our x is positive here, we're going to open in an x direction and hug those asymptotes. So I can see that my two vertices are 4, 0 and minus 4, 0. And to find my foci, I'm going to do c squared equals, now remember this is plus 25 plus 16, which is 41, and c is plus or minus root 41. So my foci are root 41 comma 0 and minus root 41 comma 0, which is a little bit more than 6, because 6 squared is 36. We get 6.4. So 4, 5, 6, put it here and here. These are our foci. So while we are going to normally work with hyperbolas that are centered at the origin, it is possible to translate these axes. And in order to do that, we basically shift it in the same way that we shifted our ellipse or our circle by making the x squared an x minus h squared and our y squared a y minus k squared. In that case, our center is going to be hk. So I am going to just do this one example here. This is a hyperbola with a translated axis. First thing I would look at would be my center. And I can see right here that my center is 3, negative 2. So right here. Now what we've done when we say translate the axis is we're now going to kind of think of this as our origin. And so in the x direction, I'm going to go 3 here and here. And then in the y direction, I'll go 5 here. And I'll draw my magic box. Once I have my magic box, I will draw in my asymptotes that go through the corners and the center. And then I notice that this one starts again with an x squared, so it's going to open in the x direction. Remember that if it opens in the y direction, the y squared is going to be first, or at least positive. Okay, so these 2 points, blue points here, are our vertices. And we can just look at the graph here. So I could do a couple of things. I could do 3, negative 2, and then say, well, from that center point, I went 3 plus or minus 3 in an x direction. So I could add or subtract 3. So my vertices here are going to be 0, negative 2, and also 6, negative 2. The only intercept that we have here, these are going to be the x-intercepts. Well, we can find x-intercepts by letting y equal 0. So if I let y equal 0, let's do that here for a second, minus, if I let y equal 0, I'll get 4 over 25. And then just to make things easier, I'm going to make it 25 over 25 for 1. So if I add 4 25ths, I get 29/25. If I multiply then by 9, I get 261/25. And then I can take the square root of each side and then add 3. So we're going to get our x-intercepts are 3 plus or minus the square root of 261. And if we take the square root of 25, we'll get that 5. So these are our x-intercepts. It was already in standard form. And let's talk about those asymptotes. So we know that the slope is up 5/3. So for both of our asymptotes, it's up 5/3. So let me show you up here. So we could say that it was 5/3 or minus 5/3 for our slope. But in either case, we know that they both go through the point 3, -2. So then if I use my point slope form, y minus y1 equals the slope times x minus x1, I will get my equation. And we could simplify this. Y equals 5/3 x minus 7. And look, 1, 2, 3, 4, 5. Look, it's right there, minus 7. That's one of our asymptotes. And then for the other one, also going through 3, -2, we get y plus 2 equals -5/3 times x minus 3. So on this side, minus 5/3 x plus 5. So we'll get y equals minus 5/3 x, and if I subtract 2, I get plus 3. And again, you can see that on the graph. Sometimes it's not a nice whole number, so it's important to know how to do that. Okay, now let's take a look. So in this example, we want to find the equation of a hyperbola in standard form satisfying the given conditions. The vertices are 0, -3, and 0, 3. So I'll mark those there on that graph. And my foci are 0, 5, and 0, -5. So you can tell that this is my transverse axis. And so it's going to open in that y direction. And so we know that we're going to have y squared over something minus x squared over something equals 1. And I should note, I didn't say that we can tell that the center here is 0, 0. So what we need to do is fill in these two values down here. And I can already tell that in the y direction, I went 3. So underneath that y squared, I'm going to do 3 squared, or 9. To find the other piece, we take our c value, which was that distance, 5, and we say c squared equals a squared plus b squared. So in this case, 25 equals 9 plus b squared, and we get b squared equals 16, or b equals 4. So for our b squared here, we can put a 16. This is the equation. And then if we wanted to finish this, we could go 4 in the x direction, here and here. And we could draw our little magic box with the vertices and those intercepts. And we know it's going to, oops, we got to draw those asymptotes in. So straight through that center and those corners. And we know it opens in a y direction because the y squared was first, and that's our transverse axis, and it would look something like this. For our last example, we also want to find the equation of the hyperbola. We're told that one of our vertices is at 2, 0, and that our asymptotes are 3/2 x and minus 3/2 x. And so for both of these, the y-intercept is 0, and we can go rise over run for our first asymptote, positive, and then negative would be rise 3 back 2, and we would get this. Now remember, these asymptotes went through the center, which is 0, 0, and they also went through the corners. So that allows us to kind of sketch our magic box in here. So that appears that our second vertex is at negative 2, 0. Now vertices are on the transverse axis, so these are going to open in an x direction on the x-axis, which means our x squared is going to be first. And since our center is at 0, 0, we don't need to translate it. So we only need to find these values here to find the standard form. And we can see that from the center we went 2 in each direction. And so in the x direction, so 2 squared is going to give me 4. And then in the y direction, I went 3 in each direction. So I'm going to put underneath the y squared 3 squared, which is 9. And so this is the equation that has those properties. That concludes this video on hyperbolas. I hope you've learned something.